Imagine your spacecraft closing in on Jupiter. At first, it almost looks beautiful. Soft bands of cream and orange, a giant red storm turning slowly in the clouds. A world so bright in the darkness, it feels almost familiar. The closer you get, the faster that illusion falls apart. Radiation levels climb, instruments start to struggle. The magnetic field grows stronger by the minute. And somewhere in there, the truth sets in. You're not approaching a planet. You're approaching the most powerful force in the solar system after the sun itself. Jupiter isn't just large, it's overwhelming. At roughly 140,000 kilometers across, it's more than 11 times wider than Earth. More than 1,300 Earths could fit inside it. And it holds 2.5 times more mass than every other planet in the solar system combined. It's so massive that the shared center of gravity between Jupiter and the Sun doesn't even sit inside the Sun. It falls just outside the solar surface. In a very real sense, Jupiter doesn't simply orbit our star. The Sun and Jupiter both swing around a point between them, and Jupiter came close to becoming something even stranger. With enough extra mass, it might have crossed the threshold toward a star-like object, but it never ignited sustained fusion. Instead, the solar system was left with something almost more unsettling. A giant world with no solid surface, crushing pressure, deadly radiation, and enough gravity to shape the fate of everything nearby. Look at Jupiter's atmosphere, and you're not watching weather in any familiar sense. You're watching violence, organized into bands. The Great Red Spot alone has raged for centuries. A storm large enough to swallow Earth whole, with winds outrunning the strongest hurricanes on our planet. Around it, jet streams tear across the planet in opposite directions, carving belts, zones, and vortices that can easily outlast entire civilizations. But the storms are only the surface of the problem. Jupiter has no ground at all, no place to land, no rock beneath the clouds, no floor waiting anywhere below the atmosphere. Fall into Jupiter and the gas simply thickens around you. Pressure climbs, temperature rises, the atmosphere turns fluid, then stranger still, until hydrogen itself gets forced into an exotic state. Liquid, metallic hydrogen. That layer is one of the keys to Jupiter's power. Deep inside the planet, metallic hydrogen conducts electricity, and combined with Jupiter's rapid spin, it generates the largest, strongest planetary magnetic field anywhere in the solar system. Earth's magnetic field protects life. Jupiter's does the opposite. It builds a radiation trap, capturing charged particles and accelerating them until the space around the planet turns lethal. An unprotected human caught in parts of that radiation belt wouldn't survive minutes. Even machines struggle out there. NASA's Juno spacecraft, in orbit since 2016, carries its electronics inside a thick titanium vault built to slow the damage. And even then it survives only by following carefully planned orbits that limit how long it lingers in the worst regions. Jupiter doesn't welcome visitors. It wears them down. That violence doesn't stop at the clouds either. Jupiter's gravity helps shape the entire architecture of the solar system. Early on, it may have migrated through the young disk of planets and debris, scattering material and deciding which worlds got the chance to grow. One model, the Grand Tack hypothesis, suggests Jupiter once drifted inward before Saturn's gravity dragged it back out again. And if that happened, it could help explain why Mars stayed so small and why the asteroid belt never pulled itself together into a planet. Jupiter didn't just join the solar system, it edited it, and in some ways, it's still editing it. Comets and asteroids that wander too close get captured, shattered, swallowed, or flung onto entirely new paths. Sometimes that shields the inner planets from danger. Sometimes it sends the danger inward instead. A gravitational weapon that cuts both ways. In 1994, the world watched that power play out in real time. Comet Shoemaker-Levy 9, already torn apart by Jupiter's gravity, slammed into the planet fragment by fragment. The impacts released almost unimaginable energy, leaving dark scars in the atmosphere bigger than Earth itself. Something like that happening here wouldn't just be a disaster, it would be the end of an age. Jupiter's most fascinating prisoners, though, are its moons. Io, the innermost of the four Galilean moons, is the most volcanically active world we know, not because it generates its own heat like Earth, but because Jupiter's gravity needs it over and over, stretching and squeezing its interior until it melts and erupts. The volcanic material it throws into space becomes electrically charged, feeding Jupiter's magnetic environment and helping power auroras far stronger than anything Earth produces. Europa tells a different story. Beneath its icy shell sits a global ocean, one of the most promising places in the solar system to search for life. But Europa also orbits deep inside Jupiter's radiation belt, its surface bombarded constantly. So anything living there would need to be sealed away below kilometers of ice, well out of reach of the radiation above. Ganymede, the largest moon in the solar system, even generates its own magnetic field, the only moon known to do so, and still exists entirely under Jupiter's control. None of these moons are peaceful companions. They're worlds held hostage by the gravity and radiation of a giant. That's what makes Jupiter so hard to describe cleanly. It's dangerous in every direction at once. Storms that could swallow Earth, pressure that unmakes ordinary matter, radiation that kills in minutes, gravity that reshapes entire orbits, a magnetic field that turns empty-looking space into a hazard. There's no safe version of this planet. And yet, we keep going back, because the same things that make Jupiter terrifying also make it scientifically priceless. Its atmosphere teaches us how giant planets behave. Its magnetic field works as a natural laboratory for plasma physics. Its moons may hide oceans, volcanoes, and real clues about life beyond Earth. Its history may explain why the rest of the solar system looks the way it does. Juno alone has rewritten a good chunk of that picture. A core that may not be a clean solid mass, but a diffuse, fuzzy region blended deep into the planet. Storm bands that reach far below the visible clouds. Polar cyclones arranged in strange geometric clusters nobody expected. A planet more complicated than the simple striped ball we thought we understood. Still, Jupiter remains permanently out of reach. We can study it, orbit it carefully, send probes diving into its clouds, but we will never stand on it. There's no surface, no safe altitude, no stable frontier where anyone could build a home. Jupiter isn't a destination in any human sense. It's a boundary. A reminder that not every world in this solar system exists to be touched. Look up on a clear night and Jupiter appears calm, a steady, almost gentle point of light. But that light is coming from a world built out of storms, pressure, radiation, gravity, and violence too vast to see from here. A world that helped sculpt the solar system, that may have shielded Earth and threatened it in equal measure, so massive that even the sun bends its path around it. Jupiter isn't the king of the planets because it's noble. It's the king because everything nearby ultimately answers to its gravity.